minute. Something ain't right.
Nabuto na.
Ano yung nakaraan? Ayun ba yung nakaraan? Sunod-sunod to.
Ako hindi ko yan eh. Yun.
Magpas kasi yung tagwan.
Uy!
Uy!
Ayan lang.
Ay, ito yung ako.
Kaya nila gumagod pa rin. Ay, stop. Lubat na yung battery.
May Johnson ba yung
Kaya gumasod pa rin kahit na mali doon. Pwede yun nasad. Kaya nga, hindi gumasod pa rin.
Hindi, meron din kasi yata ng ganito na
Moment of truth. Hey! Moment of truth. Moment of truth. Hey! Hey! Hey!
Hello po. We are the group 1, and we had performed our experiment number 4. Before that, we have done a experiment 3 called line following, and for experiment 4, we did a short AI shortest path. And for our observation and recommendation,
Observation and recommendation. My observation is that when we use the 7 IRs, I observed that we were able to get more precise and accurate actions or movement from our robot. Using 7 IR sensors allows us to make more precise adjustments in the line following portion of our robot. This is due to the fact that we were allowed to make more combination with the IR sensor, which can be used as a condition in more if statement. I also observed that representing the offset of the car from the line as error proved to be effective in setting the speed of the motor. The farther the center of the robot from the line, the larger the value of the error, which we multiplied to a proportionality constant, which will result to the actual speed of the robot that will be subtracted and added to the speed of both motors to achieve differential speeds. This allowed the motor to achieve to perform turns and alignments with more accuracy and finely tuned motion. I also observed that creating modes with the robot proved to be useful, especially in dictating what the robot should do, and to avoid overlapping between any of the void functions created. Also, by creating modes, one can easily diagnose where the errors and issues are coming from. This mode can also be used as a condition or switch to future void functions. With that being said, I also found that creating void function for a specific action or command proved to be convenient in creating a loop which requires a command or action to be repeated. This eliminates the need to type every syntax over and over again. So for my recommendation, in making the line following and may solve a robot, I suggest to make use of numerous number of sensors. The same with ours, or it can be more depending on how accurate you want your robot to be. Alongside the multiple IRs, I recommend to use more constant or an equation which will result in more accurate value compared to the proportionality constant. Although it proven to be effective, but it is still lacking if you want more accuracy and finely tuned motion. I also suggest to keep your code in order and neat. Due to the length and content of the code, it sometimes proves to be difficult to navigate in. Therefore, making orderly code proves it make it easier for the programmer to identify errors or mistakes in the code. Lastly, I suggest to use batteries which will be able to power your robot for the required amount of time.
So, for my observation, in this experiment, we created an algorithm that will simplify the path of the starting point to the destination of the smart car in the shortest possible way. Upon figuring out the necessary code for this algorithm, we come across various problems, errors, and even remodeling of the physical appearance of our smart car. For instance, we encounter problems with the alignment of the 7IR sensor's position, wherein when we run a code for the line following, the far right and far left sensor also read the path that's supposedly for the 5 sensors only. Thus, we come up with an idea to adjust the placements and move the 2 sensors away from the sensors in the middle, since the 5 sensors in the middle are for the detecting path accuracy, and the 2 sensors uh, in the side are for the detecting right and left movement of the smart car. Moreover, we also perform trial and error on our delay function to obtain the desired action of our smart car. To be specific, the delay on each dead end of the path for it, the dead the dead end of the path for it when the smart car detects an end, it will turn around in a precise manner and return to the path. Lastly, instead of adding a switch as stated in the procedure, we use the delay function since we already lack of resources. However, we also had a little problem with it, in which before we place the smart car in the starting position for the second run, it was already performing the code. Thus, we resolved the problem by assigning a larger delay time. And for the recommendation, I encourage to do a step-by-step method like what our group did, since in this manner, you can easily recognize the errors depending on the uploaded code in the Arduino. However, it will be moreover, it will be convenient to resolve the software problem and the hardware modifications. I also recommend not to restrict ourselves in conduct a series of trial and errors, for it will be useful in obtaining the desired action of our smart car.
So for my observations and recommendations, in performing this experiment, I have observed about the coding and the way it was built for the smart car to correctly navigate throughout the paths laid out by the group. Due to the remodeling of the robot and the use of se- 7-line tracking module, the code was only built for the code was specifically built for the rotations, delays, reading of the track to record the shortest route possible towards the goal. Well, lots of trials and errors were executed and needed 2 meetings to complete the whole code. For my recommendations, it is important to think outside the box when performing codes and using the available resources around us. There was no need to stick with the main parts of the robot and waste time forcing codes which may seem impossible for the algorithm and the parts. Take time to ponder and think critically to solve the problem to be addressed, and surely you will obtain the results you needed. That's all.
So here are my observations and recommendations. In our experiment, we used 7 IR sensors, 5 in the middle and 2 on the far ends. From the 5, The middle part indicates that the car follows the black path, while the neighboring four stabilizes the car's direction according to the black tape path. Another interpretation of the four sensors function is, let's say, at least one of those four read the black path. That states na offset yung car sa path. Then, the Arduino will command the motor to adjust the car so that the middle sensor will readjust to the path. I noticed too na kapag mas malayong sensor ang makaka-detect ng path, mas sharp yung turn or adjust, which gives me assumption that the more sensors on the the middle part, the greater the coping of the offset distance from the center path, thus less error. The two extremes on the other hand, yung part 2, their technical purpose is to trigger whether the car must turn left or right. Another thing is we place the caster wheel closer to the middle because we notice that the car swerves more than the wheel is at the back. For the direction fundamentals, the forward, left and right turn, and reverse are as similar as the ones we did in experiment 2. We added a new term which is called 1 inch. During 1 inch command, the car accelerates with the same speed as the forward but only in 250 milliseconds. Its main function is to allow second sensor reading upfront since in some cases the initial readings are not sufficient enough to distinguish a path. So that's for my observation. Then for my recommendation, make sure your wheels have a good traction or good grip. If it is not, then modify it. Either you coat it, apply any material on it, or replace it with uh, wheels with higher traction. Another thing is the weight distribution of the smart car must be roughly equal to avoid swerves or leaning forward. That's all.
So, hello and good day. For my observation, I have observed that for the smart car to perform the given task for the fourth experiment, other components won't be necessary and may be removed from the original build as it may not be used for the time being. Furthermore, the car required additional line tracking modules to collect and record a more precise data from the path it will be passing through. Due to the task given for this experiment, which is to be able to find the shortest path and solve the maze, the coding utilized the past experiments codes as it proved to be really relevant for the matter, except that the group needed to add some other programs. And as for my recommendation, I recommend using the past programs as references and incorporate it with the ones we may see from other sources such as the internet. And aside from this, it is also recommended to be able to produce a makeshift part as the experiment required us to use 7 IR sensors and there was no available part to cater all of the sensors in front. Well, for the time being, so we were forced to make a part that will hold all of it for us to be able to proceed with the experiment. So that's my observation and recommendation for the fourth experiment. Thank you.
So my observations on the mechanics of the car is mostly based on the path which it is taking. First, the default right command. The smart car will prioritize to follow the path to its left, meaning it will go to the left even if it detects a path going to both its left and right, including a path to the north sometimes or a straight line ahead of the car. We added the 1 inch command to the commands of the smart car for it to move an inch so that the sensors will be able to confirm if there are still other paths or lines on its way. First case will be a path going to its left. The smart car will turn to its left without moving an inch forward. So next, if the car detects a single path going to its right, it will move an inch forward. Then it will be forced to turn to its right, because even if it is a default left, it will still take the right lane or the right line if there are no other paths ahead of it. So next will be the smart car, or another situation is when there is a path perpendicular to the smart car going to the opposite sides of it. The response of the smart car to this will be to move an inch forward, then take the path to its left. So since it is a default left, it will prioritize the left path. Next situation will be a path that has a straight line ahead of it and another line on the right side. So it will form like an L, letter L. Then so um the response of the smart car to this is to move an inch forward, then take the straight path ahead of it. It will ignore the line going to the right. Oh, so another one is if there is a dead end path, meaning there are no other lines ahead or on the both sides of the car will move an inch forward, then it will turn back and take the path going to its opposite side. Lastly, if the smart car detects a black color after it forwarded an inch, meaning uh, i- meaning it already detects a line or a black color, then it still detects a black color after it moves 1 inch forward. It will stop. Then next is the taking or after taking the track for the first time, the smart car will calculate the shortest path from the starting point to the end. So when you put the smart car from the same starting point as the previous one, it will take the shortest path to the end of the track. So um, we need to remember to put the car on the same starting line or starting point. So my recommendations, uh, the track of the smart car will affect its original position and the movement of the wheels, even affect the sensors. Either way, you should trust your car because in the end, it will still be accurate, calculating the shortest path to the end point, even if you encountered a dirt or sometimes um other black things on the path that will make your car um stop or do something that you didn't expect. The car will still calculate the shortest path on the second try. So you need to trust your car and don't panic. That's all.
My observation in this experiment number 4. In this experiment 4, more problems arises than the previous experiments combined. Not only we tackled about how we will try to make a maze solving code works, but also some hardware technicalities. We did adjust the third wheel for sway difficulties in order to have a more precise turn and to lighten the challenges we've had towards the code. Making a smart car to use 7 sensor pushes us on our limits due to our batteries getting drained before we even try to accomplish a major step on coding. Low battery charge means less power and inaccurate turns for the motors. And as for my recommendation, if a simil and as for my recommendation, if a situation arises wherein the code is expected to perform well but did not execute properly, check for other factors that can be changed. For example, the adjustment of the wheel for the less way and more efficient turns, and having a better battery when it comes to adding more components to the smart car to supply more power. And that's it for our observation, discussion, and recommendation. Thanks for watching, and we hope to see you again very soon. Bye.